In this video, I am going to walk through the solutions for the problem solving chapter 10 set. And this video will focus on question number 1, and there will be additional videos that focus on questions 2, 3, and 4. You can download a copy of this handout by going to the Canvas page for the course and going under Files. You should see a folder there for problem solving sessions. You can download this worksheet and give it a shot on your own before you go through this solution set. Use this video solution as a way to verify your work and to work through places where you may be stuck or hung up, and to hear strategies about how I would go about tackling these types of problems. So in question 1, we're asked to provide the IUPAC name for each of the following molecules, where you see several different themes of structures where alcohol functional groups appear. That's the OH group, also known as the hydroxy group, present in each of these molecules. The thing that you need to remember first and foremost when we're thinking about naming alcohols is that when we are deciding how to number a chain or where to start numbering a ring, the alcohol group is going to take priority over the other types of functional groups that we have talked about so far this semester. So the alcohol is going to take priority over the alkene group, alkyl groups, or alkyl branches as you might call them, and halogens when we decide where to start numbering our longest carbon chain, or when we decide how to start numbering our ring. So for nomenclature, the alcohol is going to take priority over those other functional groups in anchoring where our carbon chains need to start. We will start a carbon chain at the end closer to the alcohol group. We will start numbering a ring at the carbon that bears the alcohol group. So in the case of this structure that we have here in part A, we have a 7-membered ring, and our 7-membered ring will always have that hydroxy group, the highest ranked group there, coming off as the branch at number 1. Then we take the shortest direction around the ring to get to our next branch. So that's going to put the chlorine branch there at carbon number 3. So our parent name for this molecule, since we have a 7-membered ring, remember to use the word cyclo in the name. That's a really common, one of those silly overlooked type mistakes that people make, so don't fall into that trap. So cycloheptanol, and you don't really need to put this in as cycloheptan 1-ol, because it's implied that that alcohol group has to be at carbon number 1 of the ring, since the alcohol takes priority for deciding how to name the ring. So cycloheptanol will be fine as our parent name and indicative that there is that alcohol group there because we have that OL suffix. And then we need to name our branch coming off of that. So the branch that we have here is a chlorine branch, so we'll call this 3-chloro. And the word chloro runs right into the word cycloheptanol. And then we're not quite done yet, because remember that the configuration of the molecule is important in determining such things as its biological effects. And so we need to go in and determine the configuration at each of the 2 stereocenters in the molecule. So there's stereocenter here at position 1 and a stereocenter at position 3. So let's focus first on position number 1. At position 1, we have to assign the relative rank of the 3 groups there that we see, plus keeping in mind that there's a 4th group there hiding, the hydrogen atom. The hydrogen would have to be on a dash pointed away from us, since that's the only piece of the tetrahedron that is missing here. And ranking our 4 groups, hydrogen, of course, is ranked last. I'm going to ignore that. The hydroxy group is ranked highest because oxygen has a higher atomic number than carbon. Our second highest ranked group would be coming over this way. Third highest ranked group is coming over to here. And so going from 1 to 2 to 3 takes us in a clockwise direction with the hydrogen pointed away from us. That is indicative that this is going to have the R configuration at this stereocenter. We will be plugging that into the name in a moment. We can then go over to our other stereocenter here at position 3 with that red star on it, and we'll rank the 4 groups that are bonded there. Keep in mind the hydrogen, which is not shown, it's implied, is on a wedge here, because that's the missing part of the tetrahedron. Highest ranked group is the chlorine. Second highest ranked group is going to be coming this way toward that hydroxy group. Third highest ranked group is coming this way. So going from 1 to 2 to 3 takes us here in a counterclockwise direction. And since the hydrogen points toward us rather than away from us, that indicates that this is an R configuration stereocenter here. So now we'll go ahead and fill that information in to our name. So I'll zoom back out here, and plugging this in to the prefix of the name here, we put our parentheses. Within our parentheses, we indicate the configuration of each of the two stereocenters. Since there's multiple stereocenters, we have to indicate a number here to indicate which stereocenter we're referring to. So at position 1, we have R configuration, so I'm going to put 1R, and then comma. At position 3, we have an R configuration as well. So 1R, 3R, 3-chlorocycloheptanol is going to be the complete IUPAC name for this molecule that you see at your left. So let's go ahead and do the same sort of system for determining the IUPAC name in part B here. So for part B, we need to establish the longest carbon chain in this molecule. To establish the longest carbon chain, I'm going to start here at this end, just rolling through the molecule, finding my longest pathway I can trace out without lifting my pen or pencil. So I get to here, where I've ended highlighting in gray, and I have a choice to make. I could either take the branch up to the right or over to the left. The way that we decide which path to go is first and foremost take the path that is longer, but in this case there's a tie. Whether we go to the left or to the right, our longest carbon chain is going to be 3 carbons in either case. So the tiebreaker there is if the length of the chain is going to be the same one way or the other, go with the one that would create more branches. So therefore, coming this way to our left creates more branches, and when we get to this spot here where we have the 2 methyl groups coming off at this carbon, doesn't matter which way you go, both chains are going to be the same, so we'll go up to there. So this is going to be our proper longest carbon chain in this molecule. We need to go through and sort out how many carbons are in that longest carbon chain in order to come up with the parent name for this molecule. I see there in our longest carbon chain a grand total of 8 carbon atoms, and we need to decide how are we going to start numbering this. Keeping in mind what we have written big in red at the top there, the alcohol takes priority in deciding where to start numbering our longest carbon chain. And so don't pay attention to this methyl group here at the left and let that make you think that you need to start numbering from over here. That methyl group is not the most important group in determining how to number your longest carbon chain. Start numbering from the end closer to our hydroxy group because the alcohol takes priority. So, therefore, we're going to start numbering from this end of the molecules. Number 1, 2, 3, 4, 5, 6, 7, 8. So 8 carbons in our chain. Therefore, this is a derivative of octane, or specifically, since it's got that alcohol group in it, it's going to be octan, and then 3 all, indicating that the hydroxy group branches off at position number 3. From there, we will go about coming up with the configuration and the names of the other branches. So let's tackle the branches first. So just to be clear, we've already incorporated this hydroxy group because we included OL in the suffix of the name. So what we now need to specify is everything we haven't yet incorporated in the name, which is going to be our methyl branch here, the 2 methyl branches at position 6, and then this branch here, which hopefully you recognize as an isobutyl branch. It's an isobutyl branch because it has 4 carbons in total, 1, 2, 3, 4, and it's got this methyl group coming off at the next to the last carbon right before you get to the dead end of the molecule. So isobutyl and methyl, we alphabetize those. Remember, you do include the term iso in alphabetizing because that's not a hyphenated term. So the term iso does get included in the alphabetization. And iso coming before methyl in the alphabet means that this is going to be 5-isobutyl. And then we have 3 methyl groups that we need to highlight here. So those 3 methyl groups are at position 6, and position 7. So 6, 6, 7, trimethyl And then the term trimethyl should run directly into the word octane 3-ol. I ran a little low on space there, so I had to stack it up. But 667 trimethyl octane 3-ol would be the name of this molecule, complete except for the stereochemistry. So we need to specify the configuration, and I see here in this molecule 2 stereocenters where we can provide the configuration here at position 3 that I've highlighted in pink and at position 5. So we'll go in and assign the configuration of those 2 stereocenters. So at position 3, the highest ranked group is going to be our alcohol, because an oxygen has a higher atomic number than carbon. Second highest ranked group coming over this way. Third highest ranked group coming down. So going from 1 to 2 to 3, and the hydrogen's pointed away from us, shows us that this has an S configuration. So I'm going to go ahead and fill in my brackets here at the front and plug this in as 3S. But there's more, because we also have to assign the configuration at carbon number 5. So to do that, I'm going to step over here to position 5 of our chain. And at position 5 of our chain, our highest ranked group that I'm going to write in blue here is going to be coming over here to carbon 1. That's going to be our highest ranked group there, our 1 circled. Because at that position, we have a carbon atom with a bunch of branches to other carbons, more so than if we come down to here or over to here. So then our second highest ranked group is going to be coming down to here, third highest over to here, and going from 1 to 2 to 3 takes us like this in a counterclockwise direction. And since the hydrogen points toward us, counterclockwise indicates that this is going to be R. So this is at position 5, so we call this position 5R as the absolute configuration there. Then we get to our final structure here as we move down to the bottom. And in this problem, we will find our longest carbon chain. We're looking for our longest carbon chain that includes the carbon that's bonded to the alcohol group there. So we come through the spine of the molecule like so. And we are going to start numbering at the carbon atom that's bonded to the hydroxy group. The reason we do it that way is because the hydroxy group carbon takes priority over the alkene group in deciding how to start numbering the molecule. So we'll go ahead here, and we have a 5-carbon chain. It has an alkene group and an alcohol group. And so the parent name here is going to be pent 2-ene 1. So we have our pent 2-ene 1-ol. You could have also called that 2-pentene 1-ol as well. The key there is that however you do it, you have to have that En to indicate the alkene group and the Ol to indicate the alcohol. You also have to have the numbers there, the 2 and the 1, to indicate exactly where the alkene group is located and where the alcohol group is located. So then from there, we have a couple of bits and pieces left here. We have a methyl group at position 2 and at position 3. And so therefore, we need to plug those branches in. So we're going to call this 2,3-dimethyl pent 2-ene 1-ol, or 2,3-dimethyl 2-pentene 1-ol would work as well. Then finally, assigning the absolute configuration of the molecule. When we look at position number 2, the start of our alkene, the higher ranked group goes downward like so. When we're at position 3, the higher ranked group goes upward. So with those groups going in opposite directions, we would describe the absolute configuration here as being the E configuration. So you need to plug E here at the front of this to indicate the absolute configuration there of this molecule. You could also refer to this as trans 2,3-dimethyl, etc., because in following the longest carbon chain through the molecule, the longest carbon chain is running trans relative to that alkene group.